Hello everyone, myself R. Venkatesh, working as Assistant Professor in the Department of Computer Science and Engineering at Vignans Niluru. Today I am going to discuss about the challenges of implementation in data mining. So although the data mining is very powerful, it faces many challenges during its execution. Various challenges could be related to performance, data, methods and techniques, etc. The process of data mining becomes effective when the challenges or problems are correctly recognized and adequately resolved. So, coming to the challenges, the first one is incomplete and noisy data. The process of extracting useful data from large volumes of data is data mining. The data in the real world is heterogeneous, incomplete, and noisy. Data in huge quantities will usually be inaccurate or unreliable. These problems may occur due to data measuring instrument or because of human errors. So you can consider the diagram here. So here we are having three different types of colors. One is yellow, blue and red. So the yellow represents the missing data and the blue represents the inconsistent data and the red represents noisy data in a collection of data around the world. The second one is data distribution. The real world's data is usually stored on various platforms in a distributed computing environment. It might be in a database or individual systems or even on the internet. Practically, it is a quite tough task to make all the data to a centralized data repository, mainly due to organizational and technical concerns. For example, various regional offices may have their servers to store their data. It is not feasible to store all the data from all the offices on a central server. Therefore, data mining requires the development of tools and algorithms that allow the mining of distributed data. The next one is complex data. Real world data is heterogeneous and it could be multimedia data including audio and video, images, complex data, spatial data, time series, and so on. So managing these various types of data and extracting useful information is a tough task. So most of the time, new technologies, new tools, and new methodologies would have to be refined to obtain specific information. Next one is performance. The data mining system's performance relies primarily on the efficiency of algorithms and techniques used. If the designed algorithms and techniques are not up to the mark, then the efficiency of the data mining process will be affected adversely. The next one is data privacy and security. So one of the most common issues for individuals and both private and governmental organizations is privacy of data. The field and operations of data mining normally leads to serious data security and production issues. Data mining usually leads to serious issues in terms of data security, governance, and privacy. For example, if a retailer analyzes the details of the purchased items, then it reveals the data about buying habits and the preferences of the customers without their permission. Next one is data visualization. In data mining, data visualization is a very important process because it is the primary method that shows the output of the user in a presentable way. The data visualization is the graphical representation of information and the data. By using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to see and understand the trends, outliers, and the patterns in the data. The extracted data should convey the exact meaning of what it intends to express. But many of times, representing the information to the end user in a precise and easy way is difficult. The input data and the output information being complicated. Very efficient and successful data visualization processes need to be implemented to make it successful. So coming to the next one, the data attribute types. What is an attribute? So it can be seen as a data field that represents the characteristics or features of a data object. For example, for a customer, the object attributes can be the customer ID, address, and etc. So we can say that a set of attributes used to describe a given object are known as attribute vector or the feature vector. There are different types of attributes. So this is the first step of data processing. So we differentiate between different types of attributes and then pre-processes the data. So here is a description of attribute types. There are two types of attributes. The first one is qualitative and the second one is quantitative. So coming to the qualitative attributes, the first one is nominal attributes, so which is related to names. So the values of a nominal attribute are names of things, some kinds of symbols. Values of nominal attributes represents some category or state, and that's why nominal attribute also referred as a categorical attributes, and there is no order among values of the nominal attributes. You can consider the example here. So we can consider the attribute and values. For colors, we are having different types of colors: black, brown, white, yellow, red. And we are having the categorical data here, the lecturer, professor, assistant professor, associate professor, etc. The second one is binary attributes. The binary data has only two values or two states. For example, yes or no, or affected or unaffected, true or false. Again, the binary attributes are divided into two types: symmetric and asymmetric. So symmetric means both the values are equally important, like gender. And the second one is asymmetric, so both the values are not equally important. So we can consider the diagram here. The next one is ordinal attributes. The ordinal attributes contains values that have a meaningful sequence or ranking between them. But the magnitude between the values is not actually known. The order of values that shows what is important but don't indicate how important it is. You can consider the diagram. So we're having the attribute and the value. So we're having the grade, that is A, B, C, D, E, F, and we're having the basic pay scale like 16, 17, 18, like that. Coming to the second type of attribute, that is quantitative attributes. So in this, the first one is numeric. A numeric attribute is a quantitative because it is measurable quantity represented in integer or real values. The numerical attributes are of two types. First one is interval and the second one is ratio. An interval scale attribute has the values whose differences are interpretable, but the numerical attributes do not have the correct reference point, or we can call 0 points. Data can be added and subtracted at any interval scale but cannot be multiplied or divided. Consider an example of temperature in degrees centigrade. If a day's temperature of one day is twice of the other day, we cannot say that one day is twice as hot as another day. The second one is the ratio scale. So the ratio scale attribute is a numeric attribute with a fixed 0 point. If a measurement is ratio scale, we can say of a value as being a multiple of another value. The values are ordered, and we can also compute the differences between the values and the mean, median, mode, and the quantile range, and fine number summary can be given. The second one is discrete. So the discrete data have finite values. It can be numerical and can also be in categorical form. These attributes have finite or countably infinite set of values. You can consider the example here. And the next one is continuous. The continuous data have an infinite number of states, and the continuous data is of float type, so that there can be many values between 2 and 3. You can consider this example as a continuous type. Thank you so much.